Okay, folks, welcome to Thursday's lesson. It's going to be pretty short. I'm sure you're delighted. It will mean tomorrow is going to be a slight little bit longer than maybe what a single would be, but this is where we're at. Okay, so the last day we looked at red cabbage indicator to figure out colors in acids, in base, and in neutral solution. So the last day you should have found that your indicator is ready pink in acid. It should have been violet in neutral, so that's the color you get when you boil it. And when you used base or alkali on it, it should have been blue, green, or even yellow. So red cabbage is a really great indicator because you can figure out strengths of acids and strengths of bases or alkalis really easily. So it was red. If it's a really strong acid, it was red. If you have a really what's called a strong base, it's going to be greeny yellow. But red cabbage is cool in that way. So today, again, everything that is underlined, you need to make sure goes into your good book. And you will be using your rubbish book today. So get a junk piece of paper when I ask you to use your rubbish book. So today's learning intention. So you're going to put LI in the top of your notes in your good book, and you're going to write in our learning intention, which is to define acids and bases using what's called a litmus indicator. So pause now if you need to write that into your good book. Before we get there, we just have to put a little bit of note in about acids and bases that we use in the lab. So the last day we looked at different types of acids and bases you might have in your house. But in terms of the acids and bases that you find in your lab, they will always be written on the bottles that I have in there, mostly as formulas, and there will be names in there. So you need to write in, again, the underlined words, and you need to write in these guys. So HCl stands for hydrochloric acid. This is is the acid that's found in the bag that is your stomach and helps to digest your food. H2SO4 is sulfuric acid. This is found in car batteries. H2CO3 carbonic acid is what is naturally acidic rain, and nitric acid is going to be used in the manufacture of some fertilizers. Okay, in terms of the bases then that you might find in a lab, they would include calcium hydroxide. So this is what farmers use to lower the pH of their soil. Sodium hydroxide is drain cleaner. KOH, we don't really have a use for it in the home, but potassium hydroxide, and MgOH, which is not spelt right. So can I ask you to put brackets around it and put a little number 2 here for me, is magnesium hydroxide. So if you have any milk and magnesia at home or digestion remedies, they can have magnesium hydroxide in them. I would like to now ask you to pause, write in the titles, and write in the formula for the acids and their names. Alrighty, so welcome back. Today we're going to look at a thing called litmus indicator. And as you can see from the picture, there's two different colors. There's what's called red litmus and what is called blue litmus. So there's two types of indicators, and as we said the last time, indicators distinguish between acids and bases. So we have red litmus, which is this guy here, and we have blue litmus, which is this guy here. Okay, so in the lab there are these two different colors, and they come in little boxes, and I have to keep them away from the atmosphere as much as possible because they will change color depending on what's going on or what they're stored next to. Now, you are going to write the following onto rubbish paper for me. Okay, so we're going to put PEE on top, the word P. You're going to write red litmus, and please note how I've made the word red red. You're going to have something, a space for what it is in a base, and something for what it is into an acid. So you're going to be putting a color in here and in here when you're done with your little animation. Here, this is blue written in blue, and you are going to write in what color blue litmus is in acid and what color blue litmus is in base here on your rubbish piece of paper. You are also going to write down this. So explain, this is our results, and I'll explain what this means in a minute. And you're going to put this table onto your rubbish piece of paper for me. So we have our test sample, which is acid, neutral, and base. RL stands for red litmus, BL stands for blue litmus, and when you're done here, you will have colors for red and blue litmus in acid, you will put colours for red and blue litmus in a neutral solution, and you will put colours for base in red and blue litmus. Then you are going to make a prediction. So you should know whether this is an acid, a base, or neutral. Likewise for this, and likewise for this. And I want you to see, can you now predict on the basis of the animation that is to follow what the result would be. So again, you will fill in these on your rubbish table. Okay. So if we were in the classroom about now, we would be putting on our lab glasses, you would come in to see me, and we'd be talking about our prep for this experiment. We will be using the kind of mini way of writing up, which is P. So predict, explain, expand. So we're going to use a version of this today. So explain again is this is just what is your result, and the expand is what's the science behind it. So you are going to watch the animation that's going to follow, and you're going to fill in the table in your rubbish copy. Okay, so this is just a little animation. So again, we've said there are two types of litmus paper. There's blue litmus and there is red litmus. And blue litmus, if I put it into acid, it turns red. So make a note of that. What do you think would happen to blue litmus in a base? So let's see, can we figure out? So blue litmus stays blue in a base. So next we look at red litmus, and we're going to put that into the base. So red litmus turns blue in a base. And what do you think is going to happen to it if I put it into acid? So I'll give you a hint, it was what happened to blue litmus in base. So red litmus, if you put it into acid, it's going to stay red. So last but by no means least, so we should have 2 rows out of the top of the table filled in. So things that are neither acid or base are called neutral, and a neutral substance is water. It's the only neutral substance. So what do you think will happen to the litmus paper in a neutral substance? Any ideas what it will do? Let's find out. So if you put red litmus into a neutral substance, it stays red, and if you put blue litmus into a neutral substance, it stays blue. So there's no change for either of those litmuses. So at this point now, you've watched the animation, you've filled in the table in your rubbish paper, and I would ask now that you go and you make your prediction. So you're filling in these boxes here. So what color is red litmus and blue litmus in washing soda, in vinegar, or in water? Alrighty, so we're now going to go into your good copy, and this is what you're going to write in the top. And now again, note that anywhere it says the word red, it is red, and anywhere it says the word blue, it is blue. So red litmus is blue in a base, but it's red, and it's red in acid, and blue litmus is red in an acid, and it is blue in a base. I'll summarize this in a second. So the rule would be, if it turns red, it's acid. If it turns blue, it's base. But to figure out neutral, you have to use both. So if we have a look in terms of our table, for our acid, you should have filled in that it was red for red litmus. And if you use blue litmus, it turns red. So red stays red, blue goes red. For neutral solution, red stays red, but blue stays blue. So there's no change for the litmus paper in a neutral solution. And in a base, the base red litmus turns blue and blue litmus stays blue. In terms of our prediction then, washing soda, this guy here is a base. So if it is a base, it should turn red litmus blue, and it should turn blue litmus should stay the same. Vinegar is an acid. So if you predicted that red litmus stays red and blue litmus turns red, you are correct. And water as a neutral substance is red in an acid, and it will stay blue in a base. Okay, so this whole slide is going into your good book. And that's the explain, which is the results we've said. And the last little bit we're going to do is the expand, which is the science behind it. So this is really, really important, and it's the colors, because we're going to go on to a thing called universal indicator. Okay, so this is the expand part. This is explaining the science behind it. It's all going into your good book. So acids will turn either litmus paper red. So red litmus stays red, blue litmus turns red. Bases will turn either litmus blue. So red litmus turns blue, blue litmus stays blue. And the last thing is neutral solution. And please note that I have written neutral solution in green. That color is going to be important when we get to universal indicator. Neutral will keep red litmus red and blue litmus blue. So there's no change for litmus if it's a neutral solution. And that brings us to the end of today's lesson. Now, there's no real homework other than to say you need to make sure that you have learnt red in an acid, blue in a base, and we'll go tomorrow again. Thank you.